Uh, Hello everybody. I'm going to talk about the special connection with transformers. First, I have open delta transformer. In this type of connection is normally used when one the transformer is broken or in maintenance. In this connection, one phase is removed. Open Y and open delta transformer. This connection is similar to previous connection. One phase is removed. Um, in this connection, get three phase from two phase. Uh, it's called T connection. Two line of phase 19 degree are on same. T connection. In this connection, same power is obtained, but with different voltage value.
Hi, my name is Alejandro Torres. I'm going to talk about a special connection open delta. In this occasion, there will be a time when a three-phase connection cannot be used, either by one of the transformer that composes is broken or in maintenance. That is where we use this open delta connection, where we open one of the transformer in primary side and secondary. So, like we can appreciate in the figure 1, we open the transformer C and the only voltage present for the moment is voltage A and voltage B. Voltage A is equal to voltage in 0 grades and voltage B is equal to voltage in 120 grades. So voltage C is equal minus voltage A minus voltage B. Resolving the equation here, we can appreciate that voltage C is equal to voltage in 120 grades, concluding that don't care if the transformer is open, there will be existing a voltage there.
Hello, I'm Darling Herrera and today we talk about the power in open delta connection. How much apparent power can the bank supply if one of its three transformers is removed? In principle, it seems that it could be supply only two of thirds of its apparent power since only two of the three transformers are operating. But it's not that simple, so we have to resort to the analysis of the connections and check what happens when a transformer is removed. The power in normal delta connection. The total apparent power in the transformer bank in normal operation connected to a resistive load with the angle between the voltage V sub phi and the current I sub phi in each phase 0 degrees is P expression. Power in open delta connection. While in the open delta connection, because one of the phases of the transformer is missing, the line current is equal to the phase current. Also, the currents and voltage in the transformer bank have an angle that differs by 30 degrees. Therefore, it's necessary to analyze each transformer to determine the maximum power that can be supplied. For T1, we have P1's expressions, while for the T2, we have P2 expressions. Therefore, the maximum power will be P expression. Compared to the original three-phase bank, we have P open delta above P three-phase. The available power coming out of the open delta bank is only 57.7% of the nominal value of the original bank. At first we have analyzed it that it should be 66.7%. To answer what happened with the rest of the nominal value of this connection, we must examine the reactive power of the open delta bank. Analysis of reactive power in transformers. The reactive power of transformer 1 is Q1 expression, and the transformer 2 is Q2 expression. So one transformer produces reactive power that is consumed by the other. This exchange of the energy between the transformer is what limits the power output to 57.7% instead of the expected 66.7%. Another way of looking at the open delta connection rating is that 86.6% of the rating of remaining two transformers can be used.
Hi, my name is Michelle Orara. The subject I will discuss is about the special connection delta starting complete. Uh, the open start connection is very similar to the open delta connection, except that the primary voltage are derived from the two-phase the neutral. When elimination the phase line, we are contained to the H2 to the neutral terminals and the terminal to the phase is a low voltage connection in the direction of the 240 voltage between the line to the line is maintained. With of the offsets are angles in the 30 disagree due to the configuration. Delta starts onward to this connection allow on the secondary lines to the maintains as forced lines. The phase neutral conversion and be compared with the three-phase branch equivalent. Maintain the apparent power of the continuum load, that is the line current that is maintained between to the phase is equivalent apparent power is the three lines. This begins to time the phase current and the equal the apparent power into to the phase and to the time to the current phase. The voltage drops analysis can be performed is dependent if the neutral conductor is ground on separate points. If the first case and the impedance of the neutral conductor is zero, we can conclude that is relative to the phases voltage with respect to the three-phase voltage is rated to the two tiers. Considering that the caliber of the phase and the neutral conductor are equal and the load and kilovolt ampere remain constant. We can calculate how much the loss of active powers in the power line are increasing when passing a balanced three-phase load from the advance of the single-phase transformer in complete tree. The phase connection to the power that the some load back with advantage of transforming in a complete three-phase connection. So the losses of the power and active energy causes in the primary phase that energies band of the transformers in incomplete. Connection increasing practical 40 times with respect to the band is with incomplete three-phase connection. Major disadvantage of the connection is that a very large return current must flow in the neutral of the primary circuit.
Hello, my name is Johnny Lopez. I'm going to talk about advantage and disadvantage of why open delta connection. Advantage. One of the most important advantage in this connection is that we can use in case of emergency, maybe when a transformer is disabled or broken or damaged in the normal connection Y delta. Also we know that with this connection we can feed a combination about a single phase with three phases loads. We know that in this connection we need just two transformers so we can save money and don't spend time with other connections that is dangerous. In disadvantage, we know that a high return current will flow through the neutral of the primary circuit. And other disadvantage is that losses causes in the primary feeder is 4 times higher than in a normal connection. This is everything. Thank you.